pause it and see what part's there. You get a point for your interpretation with the units, and then a point for the answer. So units are feet per second because it's velocity. So if they don't have units, if they said something about velocity, if they got the answer 6.765, then that is 1 point. So even if they don't have units or the correct explanation, if they don't have units, they can't get that second point. I would say the one they most likely got was probably the number, the 6.765. So that will get you 1 point. The second point, you have to have the units, and you have to explain that it's velocity at 10 minus velocity at 5. Yeah, I will be. I really did. Yeah. 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 If it says indicate units of measure, there's a point probably somewhere for that. So be careful. All right. Okay. All right. Okay, I'm going to flip. Actually, let me flip back through these really quickly so that if you need to go back and look at these later, that they will be there. So there is the answer for part A. There's the answer on part B. There's part C. I did not. This is the way AP set it up. I didn't.
On that last one, you would say that that's the net change.
Net change of Diego's velocity from 5 to 10. All right. Okay. All right. Yes. Well, I mean, you'll give them back to your person. Yeah. Yeah. Participation. Okay. All right. If you want to give your person their part A back, you can. We're going to look at B right now. I am now, yes. And I at least flip through the answer so you can pause it and see what it said there. Where I told it to print, it will not give you the answers on AP Classroom. The multiple choice is going to be on AP Classroom, yes. And it is online, and it will show you the answers once you've answered. What was it you asked me? Remind me. Yes. Yes.
Yeah.
Okay. All right. Okay. All right. Second one. All right, this is part B. First question. The first part asks for area of R. So you should integrate from 0 to 1, 2 minus x squared dx plus integral from 1 to 2 of x minus 2 squared with the x minus 2 with the square on the outside. You get 1 point for setting that up. Pretty much, yeah. If they left off the dx, I don't know. One time they said if you leave off the dx, you wouldn't get points. I don't know.
No, it just has like different numbers in it.
All right, so, all right. Then you should integrate. And you should get 2x minus 1/3 x to the third for that first integral. You should get 1/3 x minus 2 to the third for the second one. Or if you squared that out and integrated it, which is what I probably would have done, then you'll get something different there. But you could use a UDU substitution for that. Second point is for taking the antiderivatives correctly, so integrating both of these correctly. Write it right. And then a point for the answer, which is 2.
So, you plug in, like, where you would need and write out, like, the whole long expression.
Right. Yes, you can leave it like that. So if they did not simplify, that's okay. Yeah.
If you have an equation like x minus 2, it's like squared. In your opinion, would it be easier, like, if you have like a weird equation and it's squared, is it easier just, because like I didn't know that you could just like increase it and then just like multiply?
Well, they're doing a UDU substitution is what they're doing there.
Yeah.
So I would be careful with it. I probably would have done it this way. I would have probably written it like this. And then integrated, in which case you'll get 1/3 x cubed minus 2x squared plus 4x, which is the same as this. So it would be okay if you have that instead of the second part. It would be okay to have that.
So we get a point for setting it up, and then we get a point for
Integrating correctly for both of them.
okay. What if they like integrate on both correctly? They just did put a plus like you just took an integral of 1 and an integral.
I'd probably give it to them if they just left off the plus, but I would not give them the last point for that.
Because on the last one they did everything.
If they got a plus right here in the setup,
Yes.
I'd give it to them. I'm not sure what AP would do. I'd give it to you tomorrow. All right, let's look at part B for this one. This one is asking for region of R cross sections perpendicular that are square. So you have to do this separately. You have to do 0 to 1 and 1 to 2 separately. If they did from 0 to 2, then don't give it to them. So from 0 to 1, you have to have 2 minus x squared squared. And then from 1 to 2, you have to have x minus 2 squared squared, which is to the 4th power, but if they wrote it as squared squared, that's okay.
dx requires x.
I would give it to you tomorrow if you leave the dx off, but I know at one training that we went to, they said that you had to have the dx, so I don't know. So I would be really careful. I would try to make sure I put that dx or dy.
What if you put one and forget the other? Same thing as putting neither.
Yeah, if you don't have both, I would. So this one, you almost have to have it all right to. Yeah, you get a point for the integrands, which is this 2 minus x squared squared and the x minus 2 squared squared, or to the 4th. And then the total expression would be making sure your limits are right and adding them together. What'd you say?
What if you were to not, or just have the intervals, not have volume?
I think you'll be okay if you don't have volume equals. Are you trying to destroy somebody's grade? All right. Okay. For C, it wants region R only from 1 to 2 revolved around the x-axis. Sorry, y-axis. So we're supposed to find the volume. So first of all, you would need to, everything needs to be in terms of y. You only need to be using x minus 2 squared because you're only looking from 1 to 2 on the x-axis. So you should have pi times the integral from 0 to 1 of square root of x plus 2 squared minus 1 squared, or I probably would have written it like this because I like to do them separately. I would have written it like this, the integral from 0 to 1 of pi times square root of y plus 2 squared dy minus the integral from 0 to 1 of pi times 1 squared dy, which is the same as this. Yes.
So you could write that from 0 to 1.
Right. Yeah, and pi 0 to 1 of square root of y plus 2 squared minus 1. Put a square there if you want, but you don't have to. Dy. 37 pi over 6 is the answer. 3.
Can you just look at this? That's a lot to take in.
Yes.
Setup is right. They integrated correctly. 2 points.
Yeah.
2 points out of 5.
Well, I don't know. Let me see. They might have plugged it in right.
It's from 1 to 2. Then why is it 0 to 1?
Because you gotta look at the y-axis.
Yeah.
You gotta look at the y-axis. They give you the restrictions on the x-axis, but it's in terms of y, so it's got to be on the y from the y-axis. Yes. Let's see. Let's see. Just one, because they didn't actually integrate it. Actually, no, I think they plugged it in right. I think it's 3.
3 out of
3? Because they don't have to simplify. Oh, hold on. Here. Yes, well, that 4 right there looks like a Y, which is terribly dangerous.
That is a Y. There's no way that's a 4.
Depends on whether or not you want to interpret that as a Y. If it's a Y, then it'd be a 2 out of 3.
If they were to have set up a 1 to 2, and from there going to do everything else except for like making it
Right.
x equals, would that be like a 1 out of 3 just because?
I'd give them I think I'd give them 1 out of 3.
Just because of the
Yeah, I think that'd give them the point for the antiderivative, but not for the limits or the answer. Okay. Any more questions on that one? We need to move on. All right, number 2, last one. All right. It's number 2. I think. Oh, there was not part C on that one. D on that one. Wasn't it? Okay. All right. Okay. This last one. It was 3 points. Was it? Sometimes the progress checks don't add up to 9. So it could have maybe did that. All AP questions will add up to 9. But yeah, the last one we just did was out of 3. Okay. I think. Well, hold on. Let me check. It is out of 4. What? Oh, I'm sorry. It is out of 4. Point for the integrand. So if what they're integrating is correct, you get a point. So let me go back to who asked me the question about the integrating if they went from 1 to 2. All right. I think I'd give them 2 out of 4 if they integrated it correctly. Because I would give them a point for the integrand if they're integrating square root of y plus 2 squared minus 1 squared. And if they integrate that correctly, so if they get the y squared over 2 plus 8/3 y to the 3/2 plus 3y.
Okay, then they didn't have the minus 1 squared.
Yeah, if they don't have the minus 1, I would just give them 1. Okay. All right, this only had 2 parts. You got to find the area and then the volume around the x-axis. And you actually have to solve this one. Right? You could plug it in and leave it. So, For part A, you should be for area. You're just integrating from 1 to 4. This integral, you get a point for that. I think. Then you will. I would use the love connection here. So you end up integrating 3 square root of x minus 3 over the square root of x, or Daniel? Love connection. Yeah, they're dividing both of those by the square root of x. Yes, that'll work. Yeah. All right. When they integrate, they should get 2x to the 3/2 minus 6 square root of x, or x to the 1/2. And I believe, although there's only 3 check boxes here, this says this is worth 4 points. So I think that part would be the part that's worth 2 points. I think. Well, it says all 4 of the criteria, and then it only has 2. And then the answer should be 8, but if they just plugged it in and left it, it would be okay. And then B, you're rotating around the x-axis. So it's just pi, the formula squared, from 1 to 4. This one is 5 points, although it only has 4 check boxes. You get a point for your integrand, so the 3 times x minus 1 over square root of x, it's got to be squared, because you're integrating pi r squared, because you're rotating. Limits in your constant, if you're going from 1 to 4 and you have that pi, the pi can be on the inside or the outside of the integral. It doesn't matter. Since the area is just this area right here, you don't want to look at that empty space right there. Only if that region like touches that area. No. Yes. No, yes you can. Yes you can. Yes you can. Sorry. Multiple choice progress check. Thank you. I think it'll be similar. I looked through them. I have not worked through every single one of them. I was actually working through a few of them today, but I think it'll be similar. Yeah. I think this one. Now I haven't worked through every problem yet, or I may not, but I think this one is not as crazy difficult as they sometimes are. So it should be fairly similar.
Thank you.
All right.
The tennis team has Julia and me and Daniel on the same team.
Yes. You should get 2x to the 3/2 minus 6 square root of x. Yeah.
And these are all the people that need it. Just kick Daniel out of it. Yeah, Daniel does not need such a thing. You have an acting class, you don't need it anymore. Hey, just because I'm at 91 doesn't mean that.
91 in this class is a real A. Like a 91 in some classes is not much to brag about. But okay. All right. Part B.
Half of that, part B.
Okay, I've started in it. So, a point for the integrand here, a point for the pi and the limits. So even if whatever they're taking the integral of is crazy, if they have 1 to 4 and they put a pi out here or on the inside, they get a point. Then when you integrate that, what you want to do before you integrate is distribute that 3, square the top, square the bottom. And so they pulled the 9 out because everything up here is divisible by 9. So you can do that, or you might have 9x squared minus 18x plus 9 right there. And then, so you don't really get a point for that. When you integrate, you should get 9 pi times x squared over 2 minus 2x plus the natural log of x. Again, that 9 can be pulled out, or it could be multiplied back in. It's fine. And then the last point, the answer point, is that they have plugged in the 4 and plugged in the 1. But you're not going to be able to simplify that all the way down to a number since this is not calculator active. So I would just leave it right here. Yeah, even if they plugged it in and like did nothing, this shows like where they've actually evaluated some of it. Even if they just plug in the 4 and the 1 and did nothing, they get all the points for that. All right. All right, see if you have any questions. 2A, it was, oh wait, wrong thing. 2A is 8 if you simplify all the way down, which you don't have to. Okay. All right, questions? Trade those back. Give those back to whoever they belong to. Two, yes. All right. We were going to do a warm-up since so many people are gone. Let's not do it on the warm-up paper, but I want you to do this problem for me, not calculator active. So just work this problem wherever you would like to work it out at. There's paper.
The stack of paper I grabbed out weeks ago.
Okay, do this problem right now. We got lots we need to look at. Yes, this would be a multiple choice question. So go ahead and like simplify it down all the way to the actual number. No, this is not calculator active. If it were calculator active, it would make it easier.
So, because it's total distance, we integrate and add them.
You need to know what the graph looks like to be able to do this.
Something like that.
You need to know exactly what it looks like. I'm working on it. I'm not done yet.
Okay. No, I mean like in terms of
is not calculator active. There's no need for a plus C. Yeah. Yes.
I'm talking to him. He's had a run. He tried it out. I don't think he yeah, he's not. So,
It's not calculator active, but I'm going to double check my answer to make sure that I've messed something up. There'll be a few like this, yeah. Yeah, I mean, not a ton, because like the first three sections of this were not the volume area cross section stuff. It'll be heavier on volume area cross section, but that's what I'm getting. But I think it's wrong. Let's see. Oh, I know what I've done wrong. Yeah, it should not be. It should not be 6, Daniel. Yeah, I'll show you. It should be over 3, but I think you're still not quite right. Alright, let's see. It's not 6. It's definitely not 6.
Hey, I got 6.
If you've got 6, you're close, but not there. All right, let's look at it. I'm not quite finished, but I'll finish it here in a second. Okay, so the first thing you need to know is what this graph looks like, because when it says total distance that the particle travels, we need to think about whether or not it's positive or negative. If this was calculator active, it would be really easy, because if it was calculator active, we could just type it into the calculator like this, absolute value V of t dt, it would give us our answer right away. So it would be a lot easier if it were calculator active. And there will be, there may be some where it does show up calculator active. But because this is not calculator active, you need to know what the graph looks like. So this area right here, this area is going to be positive. But this part right here that we need to know is negative. We don't want that negative part to actually be negative because we need this absolute value. So we need to take this green part right here and we need to make it positive. So to do that, we would integrate from 0 to 2 and then 2 to 3 separately. But we would use a minus sign right here because we know that this area right here is going to give us a negative number. And so when we get that negative number, we are going to, when we get that negative number, the minus the negative will make it positive. Okay? So, or you can do them separately, get both of the answers, take the absolute value, make them positive, and add them together.
So since you found the values where y equals 0, it's negative. You only have to use those, right? You don't have to plug in more points in the function, right?
On this one, I know that's a smiley face parabola, so that lets me know where it's at. If it was something you didn't know what it looks like, you would have to kind of plug in some points to see if you're above or below. Is that what you're asking?
Yeah,
Yeah.
if it's like a graph we know.
If it's a graph you know, just go on the shape that you know. And usually if it's calculator inactive, it will usually be something you should be familiar with right here. So I'm working on my work here. So we got 8/3 plus 4 right here, which is going to give us 20 over 3. It would. And then this part right here, this part is our 6. And then this is going to be 20 over 3. So we got 6 minus 20 over 3, which is going to be 18 over 3 minus 20 over 3. So we end up with negative 2 over 3. Yeah. And then that, because we have minus a negative, because we got this minus right here, that ends up giving us 22 over 3.
I was kind of thinking that was.
So 22 over 3. So if you got 6, the problem was you were just like integrating. You were either just integrating from 0 to 3, or you were adding those two pieces together. So you got to break it up here. That's the way we deal with it if we need absolute value, but we can't actually do it because it's not calculator active. Okay, questions? 2 to 3. 2 to 3. Because they told you only to go from t equals 0 to t equals 3. If they had asked you from 4, you would go 2 to 4, but just 2 to 3. Yeah, same function, just different limits.
So if we don't know what the graph looks like, set it equals 0 to
Find your x-intercepts, and then usually you can tell, like for this one, you can tell that it's going to be up, so you can get an idea of what's above and below. Okay, so you may see something like this tomorrow. You also might see something like this where it shows up on the calculator active, and all you got to do is type it in. But if this were on calculator inactive, this is what you would have to do.
So did you stop after you plugged in all the numbers, like right there?
If it is free response, you can stop here. But be careful with your parentheses, because if they are incorrect, then you won't get credit for that answer point. But, you know, if the one I took this from was multiple choice, so you had to simplify it down because answer choices.
And if your parentheses were to be wrong, should you like solve it out all the way, but like solve it to the correct answer? Does it matter?
I think you'd probably be okay. That's a question I'd like to know what a grader would say. I know I will give you credit for it on an FRQ if you just miss a parentheses, but then are legitimately solving it correctly. But I'm not sure what they'll do on the actual AP exam. Yeah. So, all right. Let's see. Let's just do a quick review of our different types of problems that you're going to see. And then if we have any time left, we'll do a couple of the multiple choice questions from the from the progress check, which I was hoping we'd have more time for, but we don't. All right, so so some of the stuff you're going to see is going to be velocity, acceleration, average value. Let's write down average value. So if they ask us for the average value of f of x, now they might literally just ask you for the average value of f of x on an interval from a to b, right? Or they might say, what is the average velocity? So then you're going to use the velocity function as your f of x. Or average acceleration, then use the acceleration as your f of x. Right? So average value is going to be 1 over b minus a, integral from a to b of f of x dx. And whatever you're finding the average value of, that is the function that you're integrating for that formula. Okay. All right. What about if we just need to find the area under the curve of f of x on for this one, it would just be integral from a to b of f of x dx. So if you're asked for area under the curve, just straight area under the curve from integral from a to b.
But if there were two functions,
right. So area between f of x and g of x on the interval from a to b. Right, so area was easier, and you're going to see it, several of these, 2 or 3 possibly, on the multiple choice for sure, and then they usually show up on the free response as well, like we were seeing on that last one we were looking at. So area is just the integral from a to b of f of x minus g of x, assuming here that f of x is your top and g of x is your bottom. Or if we are in terms of y, so if it were in terms of y, let me write it in terms of y. So I'm going to do from c to d of f of y minus g of y dy. If we're looking from in terms of y, it would be the right function minus the left function. So that would be area between f of y and g of y on the interval from c to d. So if you see the area, there's no square, unless there's a square in the problem. There's no squares, there's no pies, there's no crazy formulas of any type, right? Just straight top minus bottom, integrate, or left minus, or right minus left, and integrate, depending on whether you're with x or y's. Okay, so we're okay here. You will see several of these things. We did not spend as much time on this stuff because it was easier to do, but it is still going to be tested fairly heavily, so be ready for those. Then let's go to cross sections. So let's say I'm going to draw a graph, and let's say we've got this green function right here. I'm going to call it f of x, and the red function, I'm going to call it g of x. And let's do from A to B. So we'll be looking at this area. Oh. We're looking at this area right here. Okay. So, cross sections, let's do, for all of these, we'll have to do cross sections perpendicular to x-axis because my functions are in terms of x, y, z, right? Yes. Cross sections are 3D, and it's not letting me write because it hates me. I think that I need to get my computer off and start again, but I don't want to because we don't have time.
Cursor up at the top bar, go to the little thing, see that. And then go back to it.
Well, let me write with the mouse.
Oh.
Can't write with the mouse. I'm going to try though,
You got it.
because it'll take too long. Okay. Alright, so if we're doing squares, that's a square right there. Alright, we would need to integrate from A to B. What's the volume formula for a square? S squared. And for this, from A to B, S would be the length of this black line right here, which would be F of X minus G of X. Make sure when you do this, close that second parentheses before you square it. Dx. If we had equilateral triangles, what was that one? That's an A to B right there. It is square root of 3 over 4 S squared. Shouldn't have that equal sign right there. Alright, our S is the same. It's f of x minus g of x squared. So you plug that in. I'm not going to do that because of how terrible my writing is right here. So S, just know it is f of x minus g of x. What about if I had this? What if I had an isosceles triangle? Isosceles right triangle with the base in the isosceles right triangle with the base in the plane right here. Basically, it's telling me that base would be my S right there. And if it's isosceles, what's the height also going to be? S. So if I had an isosceles right triangle with the base in the plane, it would be the integral from A to B of just the area of that triangle, which would be 1/2 S squared. And then you plug in f of x minus g of x for your S. Semicircles. That's a semicircle right there. Yeah, your radius is going to be S divided by 2. So you would integrate from A to B, and you would have 1/2, well, that's a 1/2, pi times the radius squared, which would be S over 2. squared. So you'd have to do f of x minus g of x and divide it by 2 right there. What else might ask? The only other one you may see is a rectangle. And so it depends on what they tell you the height of that rectangle is. So if that height is 6, then you would be integrating from A to B, and you would have 6 times S, because this base right here would be S. But sometimes they might say the height is 6 times the base, so then it'd be 6S times S, so 6S squared. So it just depends on what they tell you that height. The height could be a fixed number, or it could be a number times S. All right? Yeah, you can pull it. Yeah, I'll pull it out probably first. And same thing with like this 1/2 pi, this 1/2, the square root of 3/4. All of that can be pulled out front first. Yeah, long as it's being multiplied and it's just the coefficient. Okay, and then for your rotations, you're always pi squared. For those. So, yes. They're all of third period, first or second lunch when I'm here. So if you have questions, I will be here. Let's see. There was one on the progress check I wanted to look at before we go on the multiple choice. I always want us to get more done than we do. Okay.
I thought rotations were like different things for different situations. So we're doing, so it's all pi squared.
It's all some form of pi squared. So, let's see if this one will let me write.
Are we doing part A or part B?
This is part. I want you to do both, but we're on A right now.
So we can do both.
So, yes, I know it's a lot, but I mean, I want you to. It is okay if there's one that you read and you're like, oh, I have no idea what I'm doing. It is okay to guess it, and then whenever you submit it, it'll show you the answer so you can look at it. So please don't just guess on all of them, but if you must guess on some, that will be okay. What you're asking really quick, Levi, let's see if we'll, Eli. What you're asking really quick, so it's always pi squared, but like let's say that I've got, we could really do something similar. So let's say this top one is f of x, and this bottom one is g of x, and we're rotating around maybe the x-axis. So this area here would have a hole in the middle because you've got that outside and the inside. So I treat them as doing them separately, but it's always pi r squared. So on the outside, you would be integrating from whatever a to b, whatever limits you have on the x-axis, and you would have pi times f of x squared. I hope that didn't just make my recorder go away, did it? Okay, no, we're still recording, I think. So I'd have the integral from a to b of pi times f of x squared, and then I would need to subtract that area of the empty space in the middle, so I would integrate from a to b pi times g of x squared. So it's always pi r squared. Now a lot of times you'll see this put together, so they'll write it like this, pi integral from a to b of f of x squared minus g of x squared. So it might not be quite as obvious that it's pi r squared for those, but it's always pi r squared in some form. There. Yeah. There. Okay. I want us to look at this one problem Where'd it go? It was the calculator inactive. Oh, real quick. What about if you've got this and they ask you to find the area?
Add them together.
You have to find these two parts separately, right? Because this is going to be top minus bottom. It's different from top minus bottom over here. Yeah. But let's see. I was wanting this one. Okay. All right. Let's do this one right here together really quickly. All right. So average value of a function, f, on the interval from 2 to 6 is 3. What is the value of the integral from 2 to 6 of 5 f of x plus 2? How do we find average value? 1 over b minus a, which will be 4. Integral from 2 to 6 of f of x dx, because they tell us 2 to 6 right there. What's that going to equal? It equals 3, because they tell us average value is 3. So, how am I going to use that to find what they're asking for?
Do you plug it into the f of x?
What am I going to do with that 1/4? I can multiply both sides by 4 to get rid of it here. So I'll have the integral from 2 to 6 of f of x dx equals 12. So I can break this down over here. 5 integral from 2 to 6 of f of x dx plus the integral from 2 to 6 of 2 dx. So it's 5 times 12 plus, this is going to be 2x evaluated from 2 to 6. So it'll be 60 plus 12 minus 4, so 68 will be your answer.
I would have guessed 23.
And then, I know it's time to go. Oh.
It makes sense, but it's very.
Yeah, I figured that you would have a hard time getting there
I would have never.
on your own, because we didn't do one quite like that. Okay. All right, so